Chapter 2, number 46. A cheetah can accelerate from rest to 25 meters per second in 6.22 seconds. Assuming constant acceleration, how far does the cheetah run this time? After sprinting for just 3.11 seconds, is the speed 12.5 meters per second, greater than 12.5 meters per second, or less than 12.5 meters per second? Explain. What is cheetah's average speed for the first 3.11 seconds of its sprint? For the second 3.11 seconds of sprint, calculate the distance covered in each of those time intervals. So here are our cats, and at the start the cat is at rest at a position which I'm going to call 0. And then at the next time, which I'm going to call x2, we don't know, because we're going to be looking for that. But I'm going to call this moment t2. This is moment t equals 0. Where t2 is our 6.22 seconds. And the reason I do that is that we're also going to have the cat somewhere in between. And I'm going to draw it arbitrarily, and then we're going to talk about it to see where it should be. But I'm going to deliberately not draw it at the halfway point because we haven't really proven that. So here we go. And in that case, this is now going to be time t1 at a location x equals x1, which I don't know. What I do know is that during this entire time, the cat is accelerating with the same acceleration. Only because they told us. This is actually a terrible approximation, but they told us to assume that, so we'll do that. If we want to know how far the cheetah has run in the total time, 6.22 seconds, since I have time, I might as well use the formula that involves time. So I'm going to say that in general, x is x0 plus v0t plus 1/2 at square, which is awesome, except I don't actually have a, so I probably should get that first. And I say, well, a is the change in velocity over the change in time. And the cat ends at 25 meters per second, starting at 0 meters per second. And the clock ends at 6.2 seconds, starting at 0 seconds. So the acceleration turns out to be 4.02 meters per second square, which allows me to go up here and say that our moment x2, we would have 0 plus 0t plus 1/2 times a t2 square. So x2 would be 1/2 times the a times the time that was given squared. This turns out to be 77.8 meters. So in 6 seconds it covers about 2/3, or actually 3/4 of a football field, which is fast. Okay, part B. After sprinting for only 3.11 seconds, or exactly half the time, is the cheetah speed exactly 1/2 its final speed, greater than that, or less than that? And we know that since the velocity is proportional to the time when the acceleration is constant, then if we have half the time, we'll have exactly half the velocity. So we should end up with that v1, the velocity of this cat at the halfway point. I think we will find out, in fact, that it is 1/2 the velocity at the end, which is this. And we can do that relatively straightforwardly just by remembering that v is v0 plus at. So v1 is 0 plus at1, which is just at1, or 4.02 meters per second square times 3.11 seconds, which is 12.5 meters per second, at least if we follow all the sig figs. So we get exactly, in part B, we get exactly 1/2 as much. Part C says, what is the average speed during the first 3.11 seconds and during the second 3.11 seconds? And there are actually multiple ways to do this, but the way I'm going to do it is by just remembering that for constant acceleration, the average velocity over some time interval is just the mean velocity. In other words, it's the initial plus the final divided by 2. So here we're going to call the first trip, the first 3 point whatever seconds, trip A, and the second bit trip B, just so I can identify these from each other. And we find that V average A is going to be 0 meters per second plus 12.5 meters per second all over 2, which is 6.25 meters per second. But V average over part B is going to start at 12.5 meters per second and end at 25 meters per second divided by 2, and that's 18.75 meters per second. This allows us to do part D, which says find the distances during each of those intervals. We can actually find them in lots of ways, but probably the most straightforward way to do it is to say that V average is also delta x over delta t, so that we can say delta x during any trip is the average value during that trip of the velocity times the time, which lets us say over here delta xa is 6.25 meters per second times 3.11 seconds, which is 19.4 meters. And that over trip B, we have 18.75 meters per second times the same 3.11 seconds, or at least equal 3.11 seconds, which is 18.75 times 3.11, or 58.3 meters. And we can see that, interestingly enough, that delta xa plus delta xb, which would be the distance done during trip A plus distance during trip B, turns out to be 19.4 plus 58.3, 77.7 meters, which is almost, although not exactly, sadly, what we got up here, that we got for x2. And they don't agree because we overly rounded. I should have kept an extra digit in both cases, and then it would have rounded up to the right amount. So that's just a little bit of sig figs issue. But we find that, as we would hope, the distance doesn't matter how we break it down. Also notice that it covers less than half the distance in half the time. All right, half the distance would have been something like 38 meters, and only covers about 19 meters, or about half of what we would expect, or a quarter of the total distance.